welcome to Analytic Geometry for Chapter 8. We're going to be talking about Heron's formula, and we did touch on this very vaguely in Algebra 1 at the end of the year. It's used to find the area of a triangle when all you have are sides. So you don't have an altitude and maybe you're given all three sides, so you can't use the half base times height. So if you know the height, you can still use Heron's formula to find the area. Okay, so it's kind of helpful because you have different things, different tools in your tool belt. So I don't have a math bunny today, I'm sorry. But the first thing you have to know is what a semi-perimeter is. And this is add up all the sides and then divide by 2. So it's a half a perimeter is called a semi-perimeter. And that's what the letter S stands for in this formula. It does not stand for side. So that is where some confusion may lie. So be really careful with that. And so if you have a triangle ABC and the side links are ABC, or little a, little b, little c, then you found the semi-perimeter. Now what you're going to do is under a radical sign, you're going to multiply the semi-perimeter times the semi-perimeter minus one leg, the semi-perimeter minus another leg, and the semi-perimeter minus the other leg. So you'll have four things you're multiplying together. And so anyway, let's do an example. I think this makes more sense when you do an example. So here we have a triangle and the side links are 9, 10, and 15. It's not a right triangle and we have no idea what the height is. So we add the three sides together and divide by 2. That gives us a semi-perimeter of 17. So here is Heron's formula, and we're going to plug in 17 everywhere there's an S and plug in side A, B, and C into the formula. And then we'll simplify that. So 17 minus 9 is 8, 17 minus 10 is 7, and 17 minus 15 is 2. Now I can multiply all four of those numbers together. And remember, I still have a radical sign over that, so I'm going to take the square root of 1904 and I'll get a decimal. And that will be the area of that triangle. All of your exercises, exercises 1 through 3, is this exact same thing. Really all of them are. I'm trying to see. 4 looks exactly the same. 5, you have 2 triangles. You're going to need to add those areas together in order to know the whole figure. Alright, because this is like a really strange quadrilateral. So you're finding the area twice, you know, of the big triangle and the small triangle for number 5. So that's my hints. I want you to do numbers 1 through 5 for your whisk, but you do not have to send them to me. That's what's typical for our analytic geometry. And I will see you in class.